Hope everyone is doing well today. I am trying a brand new video recorder. The last one I used turned out to be so laggy, it was almost impragmatic to use the thing. It was so impractical I couldn't even hardly get it to update in real time. I was always skipping and scattering around, so I'm going to try a brand new device. This is the Xbox video game recorder. I'm going to try this and see if the performance is better. I don't think it can possibly be worse, so I'm hopeful, I'm optimistic. Let's just go with it and see what we get here. So this is actually my first sequel. This is going to swing back and look at a video that I posted recently. It's describing how to make API calls to fetch YouTube data and analyze the results. Okay, this is part 2 of that. I wasn't intending to make a part 2. This is the first part 2 I've ever done. It was sort of just an afterthought, but over the weekend I was looking at a couple things with the initial video, and I thought that it could be embellished and done a little bit better and just leveled up a bit. So I'm going to go ahead and do that right now. I'm not going to re-record the entire video. I don't edit these. I don't delete videos and re-record them. If there's something wrong with it, for the most part, I think I'll just leave it as is. There's not too many mistakes in the videos, or not mistakes, but like little going off on tangents or rambling. I keep it pretty tight and crisp, almost like a professor would in a lecture in a college class, right? But I don't think it makes sense to go back and redo everything that's already been done. I just want to embellish what's been done and just take it up a notch. Okay, so like I said in the prior video, we're looking at things like title, description, view count, like count, comment count, analyzing these things, right? And we got some pretty cool results. It was very interesting to see how everything was shaking out at the end. What I'm going to try to do here is do a similar type of analysis, but very, very basic type of analysis. We're not going to get into the whole weeds of it like the last video, but I want to take what's been done and then try to extrapolate or quantify the number of view counts that we're likely to get, the number of likes, the number of comment counts, and things like this, and try to quantify these numbers so we can try to anticipate what these numbers are going to grow to in the number of months. Typically, it's about 3 to 6 months, depending on how popular the video is. There could be a lag, and it could achieve greater numbers down the road, or could achieve superior numbers at the beginning and then sort of trail off into obscurity at the end, right? So it could go a couple different ways. That's what we're going to look at, and we're also going to try to predict the most likely type of title that's going to generate the most comments, and the best type of description that's also going to generate the most comments. So like if you saw the other video, you'll see you have to go ahead and get your YouTube API key. I'm using mine right here. I replaced my actual key because this is strictly confidential and it's personal. You have to go ahead and get yours. I am going to put a link in the Jupyter notebook right here where you can go and get that. Here's the URL. You can go there, and it's going to give you all the details for the API documentation for YouTube, okay? And if you scroll down a little bit, you will see the base code that I'm using right down here. If I scroll down a tad bit more, you'll see API response, and then you'll see the things that I'm seeing on my screen. So channel, title ID, description, what else do we have? View count, like count. Okay, this is how YouTube is capturing all of these statistics in a JSON format, right? And it's going to go ahead and post that when you make the request to this API, when you make a call request to the API. So you get your own YouTube API key. It's going to work exactly like you see mine working. I just deleted mine because, again, this is confidential. But it's going to work for part 1, and this is part 2. Go ahead and get your API. It's free. It's pretty easy to procure that. It takes probably 30 seconds, maybe 60 if it's the first time you're doing it and you don't quite know what exactly to do. Anyways, it's pretty easy, pretty straightforward, very streamlined process. Pop in your API key and you can run this in your Jupyter notebook and get everything that I see right here, okay? This is how I'm titling my query. It's called Data Science and Machine Learning, okay? I'm looking at IDs and snippets, and this is going to be videos, of course, and I'm going to look at 100 videos maximum. It might be less that YouTube has in its universe, right? But I think we will probably get pretty close to that $100. I'm sorry, not $100. 100 number limits because they don't want you querying hundreds of thousands of videos, right? It's going to burden the system and slow down other people that are using the network, right? So they want you to limit it to some kind of threshold here. I think 100 is good. And then you'll see right here for video and video details, this is the loop that I'm running. I want the items, the title, description, channel, publish date, view count, like count, comment count, and duration. Okay, and when I run that, when you pop in your own API key, you'll have exactly the same output here. Okay, so you see the title is here, description, you have a timeline. So this guy organized things pretty well. I don't do this really for my videos, but I've seen this done before. This is somewhat of a popular format. So if you want to jump to one section of the video, you know where it starts, right? What time duration it starts in. So here's some basic information again about. Oh, here's the next video, because we have the separator with 80 characters here. Once we get to the end, we're delimiting that with 80 characters. And then we're going to see the next description, the next title, and so forth, and so on and so forth. Okay, so this guy has similar information, a little bit more, probably a little bit more embellished than the first guy. It seems more comprehensive here. Then we have the third one right here. So AI versus ML, deep learning versus data science, and so on and so forth. Okay, so it did the API call. We got the results. That's great. Let's move down here to the next step. I am going to go ahead and convert all the durations to minutes to standardize everything, because these videos can be anything from a few minutes to way over hours. It can be multiple hours. I've seen some of these, they'll have like a single course that goes for even more than 10 hours, right? So we want to try to standardize everything in terms of minutes, so we're working in the same base unit and we can do apples to apples comparisons. Okay, so again, I'm getting title, description, channel, publish date, so on and so forth, and I'm going to stuff everything into a data frame. Okay, I want video data. I'm appending everything into a list right here. You can tell it's a list with the square brackets. I'm going to convert the list into a data frame, and then we can start to clean up the data frame a little bit and do some analysis on this. So as a list, it's useful to work on with these things in Python, but you can print items in a list, you can add to a list, you can append, you can delete. But to do real analysis, you really want to get this into a data frame. Okay, a data frame is kind of a rows and columns format of storing the data. It's somewhat like you would see in a table in a database, or similar to an Excel spreadsheet with your rows and columns laid out in front of you, right? So the data frame is a more structured form of data that we can work with a little bit easier than a list if we're trying to do some type of analysis, right? So I'm going to go ahead and take the data frame. Data frame is the data frame, right? The field is named title. I have data frame description, data frame channel, and I want to go ahead and analyze the sentiment. Okay, so I have the sentiment analysis tool, and that is going to help me to extract some useful information from the channel to get the feeling of the channel. Is this positive? Is this negative? Is this optimistic? Is it pessimistic? Give me more context and more clarity around this channel. That's what the analyze sentiment action is doing right here. Okay, so we are going to go ahead and use TF-IDF. This is text frequency inverse document frequency. I won't get into all the details here, but I have a couple other videos that explain what this is doing. This basically vectorizes everything into numeric form, so we can work with it a lot easier. So the computer doesn't really know what the word 1 or the word 2 or the word 3 is, but certainly knows the number 1, 2, and 3. It certainly knows what that is. Okay, so once you vectorize these and get these into a numeric format, it gets a lot easier to work with it in the universe of the computer, right? So humans understand text and language very well. Computers do not. So we have to go ahead and vectorize this and get it into a format that the computer will understand. Okay, we're going to do a little bit of treatment down here to get high value thresholds, and if it's a lower value threshold, I'm going to put this into a different bucket right here. So low view text or high view text. So this is going to help us understand how popular or maybe how unpopular these videos are, and then we're going to generate we're going to use this high value text to generate background color. Okay, and create a word cloud. So we're basically trying to understand how frequently or unfrequently these words are appearing for unigrams and bigrams. So a unigram is one word at a time, and a bigram is two words at a time. So we're looking at combinations of two words together, how frequently those appear, and just how one word how frequently single words appear. And you can do trigrams, quadrigrams, 5 words at a time. I forget what that's called, maybe a single gram or something. But you can look at different combinations of words. In this case, we're going to look at 1 all by itself and then 2 together. Okay, so if I scroll down a little bit more, that's what the code is doing for me right now. And I'm appending all of this to the original data frame that I started with. Okay, so I think the original one stopped with duration, then we get the title sentiment, description sentiment, channel sentiment. You saw that in the previous steps above. Then the title, description, and channel grammar. Okay, so that's what the code above is doing. And don't worry about all the details of all this stuff. It is a little bit convoluted, but it's not overwhelming. You can absolutely understand all this. It takes a little time to digest it and assimilate all this, but I'm going to give you all this code as is. So all you have to do is go ahead, download this file that I'm going to post when I post a video. It's going to be in HTML format. You can download the file. 1 click to download, 2 to open the file, and you have all this source code right in front of you. So you can go ahead and change whatever you need. Again, I don't want to spend too much time on this, but you will replace this with your own specific API key. Okay, and this is the query that I'm using. If you want to do something else, if you like, I don't know, classical music or you know, America's Funniest Videos, you see this all the time, the cats or dog or for the family are doing some crazy things. You would change the query, right, and your API key, and that's it. And then you're going to have your own results to analyze all of the TF-IDF analysis can be done for you. All you have to do is just change the query definition, right, or the threshold or the parameters that you're querying for, rather, and then put in your API key, and you'll get all of this flowing very well, very, very smoothly down here. So here's the high view count and then the low view count. So we can see this in a word count and a word cloud. These are called word clouds. And the bigger the letters and the bigger the words here, the more frequently these are showing up, and the smaller words show up less frequently. So machine learning shows up pretty frequently HTTPS because that's part of the URL. You see data scientist playlist, YouTube, Python, simple learn, deep learning. Okay, so this makes sense to me. So I think the word cloud is working. We have the high view count and the low view count. I think that's fine. We're going to go ahead and look at sentiment now. Again, we have the title and description from the original data frame. We want title sentiment and description sentiment, and then we're going to do the same thing for the grammar, right? The title grammar and description grammar. So if we go over here just a little bit, we'll see the sentiment is numeric, right? And grammar is set to true or false. So the grammar is in good shape, and it adheres to the standards of what we would define as good English grammar, or it doesn't, right? These are binary true or false results. And the sentiment is showing you how positive or how overall optimistic this is. So 0 is pretty neutral, +1 is highly positive, and -1 is highly negative, right? So we're looking at different kind of scales here. So let's move down just a little bit further. We're going to get the TF-IDF vectorizer to generate 1 column for each unique term. Okay, these are the unigrams and bigrams that I mentioned before, and these are all the terms found in the title and the description. Okay, now we started off with about, if I go back here, this is in rows and columns. We started off with 50 rows and 14 columns. Now we are up to 8,113 columns, right? So this is called a high dimensional data set now. We went from 14 columns up to 8,113. That's a lot of columns, but in the machine learning world, it's not too many columns. We can still analyze this pretty quickly and easily. I'm on a ThinkPad T14 laptop. It's not even a big data tool. This is not even cloud resources or cluster compute. If you want to get into analyzing hundreds of thousands or even millions of columns, you can certainly do that. You do have to be a little bit careful when you get into these really high dimensional data sets, though, where the computer can get sort of fooled or almost, what's the term, starts not really hallucinate, but start to misunderstand the objective that you're trying to do here. So you want to be careful of how many columns. You can certainly analyze 10,000 plus columns, 100,000, but when you get into those really big numbers, you have to be careful with that stuff because the computer can make mistakes, right? And it can take a lot of compute resources too. So you could run this, it could take hours and hours, and then maybe the computer crashes, or you get some really weird results that don't make a whole lot of sense because the computer is not able to learn what it's supposed to learn. The dimensions are too high, and it's just going off the rails, right? So we do have to be aware of this. In this case, it's totally fine, but in some cases, if you're getting several 100,000 columns, you might want to reconsider the setup and how you're handling this analysis and try a different approach, right? So let's look at the number of counts. We're going to get the median, which is the middle number, right? We always work with mean, medians, and modes in the statistics world. The median is the middle number, and we're saying anything higher than the middle number is high value count. Anything less is low value count, okay? So here's the high view for the data frame and the low view from the data frame, okay? And we're going to go ahead and plot this and look at the top features, and when I run this, we will see the plot right down here. So to get the top 10 features for high value counts, you basically need a lot of counts, right? Not exactly like newsflash here at the moment. I think we can kind of figure that out without plotting this, but it totally makes sense, right? The more counts that you get, the higher the count is going to be, and the more likes you get in a video, the higher the count is going to be. But it doesn't really have anything to do with this terminology, machine learning video, right? If people like the video, they're clicking on it, and you receive more counts. If you have the word learning or machine learning, as in this example down here, it's not going to equate to more counts or higher click-throughs, right? So that's fine. That's kind of what we expect. We just wanted to prove that statistically, okay? So then again, we have high value count, and high value threshold would be the opposite or the inverse of that. So we get high value text, low value text. We're creating another word cloud here just for a quick sanity check and see which words are coming up over and over for the high value counts and low value counts. It's interesting, machine learning comes up for both, right? Because this is bolder and it's bigger. Data science comes up for high value and deep learning, and data science comes up for low value. I don't see deep learning. Oh, I do see it on the right hand side. It's flipped 90 degrees. Okay, so so these two are kind of similar. So based on the word clouds, a high value count and low value count, it's not helping us that much really to determine what the ultimate outcome is going to be on clicks and likes and views, but it's still a worthwhile exercise, right? We don't really want to throw out too many things in the data science world. We run exercises or experiments. I'm sorry, they're typically called experiments. It could be an exercise. I guess it's based on your naming conventions or your preference, what you want to call it. Usually it's data science experiment, and some experiments aren't as useful as others. Some are tremendously useful. Some are just somewhat barely useful, but it's still good practice to run the experiment, see what the outcome is going to be, because it's impossible to make these predictions before you run the experiment, right? You come up with a hypothesis, you run the experiment, and you see if your hypothesis matches the experiment results, right? If it does, that's great. If it doesn't, you have to change your hypothesis to match what the outcome of the experiment was, right? You would never change the experiment to match your hypothesis. That's kind of insane. But if your hypothesis doesn't match, you would update your hypothesis to coincide with what the experiment is telling you, right? Those two have to be aligned. So it's still a good exercise. It's not really an Einstein moment here, but that's fine. We got what we needed out of this. So now we're going to combine the title and the description together. Okay, I think this makes sense just to coalesce these two. And in the confluence of these, we're going to go ahead and look at the independent variables. This is going to be title, description. The Y views and Y likes are going to be the view count and the like count and the comment count. So in my other videos, I explained all about machine learning, how to set up models, how to pick your independent variables and dependent variables. I'm not going to get into that here because it's too much duplication, but if you check out the other videos, it's explained ad nauseum over there. Basically, the X variable is your independent and your Y variables are your dependent variables. So Y is what you're trying to predict, right? And using the independent variables to try to make that prediction, okay? So we're going to do a train test split. Test size is going to be 0.2, so that's the holdout set. The train size is 0.8. Okay, my other videos I get into all that and what this means. The number of features is 8,111. I think we dropped a couple before. We had 8113 or something. Was that it? Let me look at this quick. 8113. Okay, so 2 got dropped off, no biggie. Apparently the model or the machine said, okay, these are not so useful, so it just kicked those out. So we still have 8,111 columns in our data frame here. We are going to use a random forest regressor and try to predict the number of views, likes, and comments that we're going to get from our video. Okay, so that's what the regressor is doing. And this is all these predictions. The y variable, remember, is the dependent. If I go back here just for a second, we're trying to predict views right here, double clicking to highlight, likes, double clicking, and comments. We're trying to predict these three values, right, and try to quantify these based on the x value right here. These are the independent variables. So that's exactly what we're doing. And we're not doing anything other than giving it a title, how to make calls to fetch YouTube data and analyze the results. Okay, this is, remember, part 2 of part 1. The first one is titled exactly that thing. I just updated the title over the weekend, so this is going to say, the other one will say part 1, this will say part 2. And then I have a short description over here that is separated by comments. I can go ahead, no, let me leave that the same. I think in the next example I'm going to change that just a little bit. So when you refresh this, you'll have the predicted views. You get 267,557.53. I don't think we need the decimal here. I don't think we'll see a 0.53 view, but you get 267,000 views. Now, what kind of time frame is this, right? It's going to be dependent on a few things. This could be the last 6 months, right? The last 3 to 4 months. Like I alluded to just a short time ago, sometimes these videos are very popular. You'll get a lot of views, likes, and comments very quickly, and then the novelty of the video wears off and kind of tapers off into obscurity, and you don't have so many comments after maybe 3 to 4 weeks, after 5 to 6 weeks. It kind of fades into the background, right? It could be more consistent where it kind of ramps up and then plateaus after 3 to 4 months, and then sort of tapers off to lower numbers. Or you could have another outcome where it ramps up very slowly and gets more popular after months 3, 4, 5, maybe month 6 is big, and the tail of this could be negatively skewed, right? So you could have a big tail to the left and just a small tail to the right. Could be a few different things, but typically within about 6 months or so, you'll see most of the views, the likes, the comments, things like that. Like, they tend to come up fairly quickly. They don't stay dormant for months and then all of a sudden get popular because of the YouTube algorithm, right? The YouTube algorithm is constantly searching for videos that it thinks that people will engage with, right? And YouTube, of course, wants you on the site as long as possible. They're going to feed you ads and serve up different ad content to you, right? So they want to promote the videos that are the most popular, and they're going to go ahead and search for that using their own proprietary algorithm and serve those specific videos, right? So the short predictions could come 2 to 3 months, but more likely it's probably going to be 5 to 6 months, okay? So that's what we see here. Now, based on what we saw above, we just predicted the views, the likes, and the comments. So I think that's really cool right there. Just based on how we trained the model, right, and this title, we gave it this title. We said, okay, with this title, how to make API calls to fetch YouTube data and analyze the results. How many views can I expect within the next 6 months? 267,000, right? And they gave a short description, right, to try to drive that value more accurately. If I gave a very brief title and kind of a nonsensical description, this number is not going to be accurate at all, right? You want to try to find the description so it matches exactly what the video is describing, right, or talking about. And you want the title to define what the video is about, right? Like, you want a meaningful title, you want a meaningful description. Otherwise, these numbers down here are really going to be meaningless, right? So the better you define it, the better the final results are going to be, right? You know the old saying, garbage in, garbage out. So we want to try to find the title, try to find the description, and then the machine is going to predict views, likes, and comments. I think it's very cool, guys. I think it's very cool. That's why I put this video together, because I didn't get into that kind of analysis into part 1, but I was thinking about it over the weekend. I thought, you know, we can actually optimize how these are done, how the predictions are made, and we can get some really cool results here, right? So that's why I created a sequel to that video that I posted just a short time ago. So here's a little more code. There's a couple UDFs defined over here. Refine text, optimize title description. So I'm doing some cleanup on the text. Again, I'm sharing all this with you, so don't worry about taking notes here and copying this down. The only thing you have to do is update your query results, right? What do you want to look for? And your YouTube API key. That's it, and everything else is just going to flow automatically down here. So it's pretty robust, it's pretty scalable, very dynamic. You change 2 small parameters and you're going to get all the results that I get. If you put in the same parameters or the same query results, you'll have the same output. If you query for something like Maestro playing piano or funny cat antics, obviously your results are going to be slightly different, but your results are going to be pretty similar in terms of the TF-IDF analysis, in terms of the number of likes, number of clicks, number of comments, things like that. It's going to be very similar. Okay, so I tried to make it very dynamic and very scalable, so you have to do very minimal work, and you can take this analysis that I've done and adapt it to your own specific situation, right? I understand it's not going to be exactly the same, but I think it will be substantially similar. You just have to update a couple basic things, and you're going to get results very specific, very customized, and tailored to your specific needs. So in this case, I'm going to go ahead and create another title, and I'm going to add a word bank. Now, instead of creating a description, I want the machine to create a description for me. So before I created the title and description, I said, go ahead and make a prediction of views, predicted likes, and predicted comments, right? That's what the analysis was for. That was the experiment. Now we're going to change it a little bit. We're going to give it, I already have the predictions, right? So I don't need that again. I'm going to give it a title, just like I had before, and a word bank. Sometimes this is called bag of words, word bank. And I'm going to say, pick from these words and go ahead and optimize the description for me, because I don't know how I want to define this as a description. I know the title is just about maybe 10 words here. Okay, pretty simple, pretty straightforward. I know what the title should be. I don't really know what the description should be to maximize the number of clicks and maximize the engagement that I get from a YouTube video. But that's what this function is doing. It's going to go ahead and optimize the number of clicks that I can receive and create a robust description that defines what the video is about, right? And generate the maximum engagement. So I'm going to go ahead and run a couple iterations, and I want the video to tell me the absolute best title. Okay, I'm giving it a lot of guidance here. I want it to be very similar to that. But in terms of the description, it can be anything as long as it includes this corpus of text, right? So these are sort of the parameters of the guardrails I work within. But again, I don't know exactly what description is going to generate the most interactions with my users, so I want the computer to tell me that. So it's going to create a couple of iterations, and then scores. As the score gets higher and higher, it's saying there's going to be more engagement and more people interacting with my video. After a series of iterations here, we get down to iteration 1130, new best score. It's 11,049, the best title, how to make API calls to fetch YouTube data and analyze the results. Intelligence to make API calls to fetch natural language processing data, analyze supervision, learning, forest results. Now that is a mouthful. I don't think that's the absolute best title, but if I remove a couple of words here, I'm actually using random forest, so I might keep that. Supervised learning, it is supervised learning, so that's true. We're doing NLP, that's true. I don't like the absolute English. I think this can be refined and just written a little more elegantly than it is. It's not very, very like refined English, but it does capture the essence of the title. And as a description, we have API integration, data visualization, explains time series decisions using forecasting, how to achieve great results. So again, it's pretty refined. It's definitely evolved from the initial past. Let's look at the final best title, how to make API calls to fetch YouTube data and analyze the results. Using intelligence to make API calls to fetch natural language processing, NLP data, and analyze supervised learning forest results. I will get rid of supervised forest learning, supervised learning, or random forest results. Just a quick little refactoring of the language here, and I think we're good to go. And best found description, API integration, using data visualization explains time decision tree forecasting and how to achieve great results. So again, I might true up that language just a little bit, but actually I think it's in a decent state. From where we were originally, where we didn't really know what the description was going to be, we just gave it the word bank right here, and I said go ahead and create a description for me. I think it's doing some phenomenal work here, and the results are very impressive. So after all that, and everything ran pretty quick and pretty easy. There's no errors. Everything's smooth, tight, crisp here. And just several seconds, we have the best title to generate the most number of clicks, most interactions from our users, and generate the most engagement. And we have the best final description. So I think this is a success. I'm going to chalk this up as a pretty major win. We have the quantitative metrics, right? We know essentially what to expect from our audience in terms of the number of clicks, the number of views, number of likes, comments, things like this, right? We got that from the random forest regressor, and then we have the title and we have the description optimized, right, to generate the maximum number of engagements with our users. So pretty good stuff, guys. I hope you learned a thing or two. Again, I'm going to post all the code so you don't have to worry about all the nuances and all the details here. Just download the code, make whatever changes you feel that you need to make, and take the liberty to do whatever you want. Take the code apart, reassemble it, put it back together again, and see how it works. And again, the objective here for me is to help you to learn these things and to help you to understand how this works, right? So you can boost your knowledge in the data science space and machine learning world, and understand these topics at a deeper level. That's my overarching goal here. Okay, so I'm going to wrap it up. Thank you so much for your time today. I hope everybody learned a thing or two. I definitely learned a little bit putting this together. I try to learn new things every single day. I hope you can too. Thanks for your time. Have a wonderful day, everybody. Goodbye.